Hello and welcome to all students. This is first year BSc class and this is unit number 1, limit and continuity of a function. So now in the previous lecture we defined what is meant by continuity of a function. We solved some examples on continuity of a function. Then we stated a algebra of a continuity function, algebra of continuity of a function. Okay, then continuity of a composition of two functions. Now in this lecture we discuss about discontinuous function. Okay, so as we know, or as we define what is meant by discontinuous function which is not continuous is called as discontinuous function. So let us define what is meant by discontinuous function now. Okay, a function f is said to be discontinuous at point x is equal to c. A function f is said to be discontinuous at point x is equal to c if it is not continuous at x is equal to c. So this is a simple definition of a continuity of a function, discontinuity of a function. Function which is not continuous is called as a discontinuous function. Okay. Now we next discuss some types of discontinuous functions. Okay, so there are many types. So following are the types of discontinuous functions. First is removable discontinuity. Second type of discontinuity is ordinary discontinuity of first kind or discontinuity of first kind. Next is ordinary discontinuity of second kind. Fourth is mixed discontinuity. Okay, so these are the four types, and the fifth type of discontinuity is oscillatory discontinuity. Okay, so all these discontinuities we will discuss one by one. Okay, so let us first discuss about removable discontinuity. First of all, we define what is meant by a removable discontinuity, then we solve some examples on removable discontinuity. So let us go to the definition of removable discontinuity. Okay, so let us define a discontinuous function f of x is said to have removable discontinuity at x is equal to c if both limit f of x extends to c and f of c exists, but limit f of x extends to c is not equal to f of c. So if our function is a discontinuous function and which satisfies this condition, limit of f of x extends to c exists, value of f at point c exists, but the limit of f of x extends to c is not equal to f of c. In this case, we say that the function f has removable discontinuity. And how to remove this removable discontinuity? By defining the value of function f at point c is equal to the limit of f of x extends to c. So if I define the value of function f at point c exactly equal to the value of limit of the function f of x as extends to c, then the function becomes continuous, and we say that the function have a removable discontinuity. Okay, so let us go now. So remark, function having this type of discontinuity can be made continuous Okay, so a discontinuous function f of x is said to have removable discontinuity at point x is equal to c if both limit f of x extends to c and f of c exists, but limit f of x extends to c is extends to c not equal to f of c. Okay, so let us write the remark. Function having this type of discontinuity can be made continuous by redefining the value of function f at point x is equal to c exactly equal to the value of limit of f of x extends to c. Okay, the remark is important. Now let us try to solve some examples on removable discontinuous function. Removable discontinuous function. Okay, so discuss the continuity of function f of x is equal to sine square ax upon x square, x not equal to 0, and function f of x having value 1 when x is equal to 0. Okay, so let us try to check the continuity of this function. Okay, so if it is discontinuous, then mention the type of discontinuity. Okay, so let us write the answer. Consider the limit of f of x extends to 0. So we check the continuity at point x is equal to 0. So consider limit f of x extends to 0 equal to limit x tends to 0. Our function is x tends to 0 means x is approaching towards 0 but x is not equal to 0. So in the case when x is not equal to 0, function has value sine square ax divided by x square, and it is equal to limit x tends to 0 sine of ax bracket square divided by x square, and it is equal to limit x tends to 0 sine of x upon x bracket square. So see here, and it is equal to limit x tends to 0 sine of x upon x into a square. Again we take a square outside, and for x we put y as x tends to 0, y is also tends to 0. Therefore limit y tends to 0 sine y upon y square. So again it is equal to a square into, if I take inside the limit, then sine y upon y has y tends to 0 has value 1, and 1 square is 1. Therefore final answer is a square. A square into 1 is a square. So limit f of x extends to 0 has value a square. Okay, and therefore we redefine the value of function f at 0 to be a square. Okay, thus limit of f of x extends to 0 is equal to a square. Okay, and it exists. This limit exists. Now also we have the functional value at, or value of function f at 0 is equal to 1, and it is also exist, but the limit of f of x extends to 0 is not equal to f of 0. This shows that the function is discontinuous at x is equal to 0. Function f of x has a removable discontinuity, and we can make this function continuous by redefining the value of function f at 0 as exactly equal to f of 0 is equal to a square. Okay, so now we define the ordinary discontinuity in the next lecture. So in this lecture we have defined what is meant by discontinuous function, and we discussed first type of discontinuity, and it is called as a removable discontinuity, and we have solved one problem on removable discontinuous function. So let us stop here. We stop our lecture. Thank you for paying attention.